Okay, so good morning. Today we are going to see DFS or depth first search traversal of binary tree. So, like other traversals of binary tree, like pre-order, in-order, post-order, we have two more traversals, and they are DFS, which is depth first search, and BFS, which is breadth first search. So today we are going to see the depth first search, DFS for binary tree. So let us go ahead. So at the end of this session, you will learn the depth first search algorithm. You will be able to demonstrate the DFS traversal of tree data structure. You will able to implement DFS traversal on binary tree data structure. So let us start with the introduction to DFS. So DFS is a technique used for traversing trees or graphs. Stack is used for backtracking in traversal of DFS on binary tree. In this DFS traversal, we'll start visiting the nodes from the root node of tree until the deepest node is visited, and then we backtrack with the help of stack to its parent node, and again we go back to the depth. So that backtracking is used for depth first search traversal, and it is implemented with the help of stack. So this is the depth first search algorithm. So we start visiting nodes from the root. In step 2, we push the visited node in stack and copy the same node into visited array. Now, in step 3, we check whether the node on top of the stack has any unvisited child. If yes, we push that child node into stack as well as copy into visited array. Otherwise, if that node having 0 unvisited children, we pop that node from stack. We repeat step number 3 and 4 until the stack is not empty. So when the stack becomes empty, the DFS sequence of visited elements or visited nodes is available in visited array. So we display that visited array to show DFS traversal of tree, and then we stop. So we repeat step number 3 and 4 for checking whether a node on top of the stack has any unvisited child. If yes, we push that child onto the stack and copy to visited array. And if no, then we pop that node from the stack. So these two steps will be repeated. So we'll go ahead and see the example of DFS on binary tree. So this is the binary tree which we are going to use. And other than binary tree, we have two more data structures which are necessary for implementation of DFS, that is stack and a visited array. So initially stack is empty. Then we start visiting nodes from root node. So we push the node, that is root node, into the stack as well as copy root node into the visited array. So this is how we pushed A into the stack. Now, as per the algorithm, check whether node on top of the stack has any unvisited child. So A, which is on top of the stack, has unvisited children B and C. So we choose any one, that is B. So push B onto the stack as well as copy B into the visited array. Now check whether node on top of the stack, that is B, has any unvisited child. So B has D, which is unvisited, E, which is unvisited. So we choose D and push on top of the stack. Now, after these steps, we'll see A, B, and D are there into the visited array. So this is the visited array where we have A, B, and D in the sequence copied from the tree. Now in the next step, the node on top of the stack is D. So as D is a leaf node, it is not having any children. So we pop D from the stack. So pop D from the stack. Now B is on top of the stack. So check whether B has any unvisited children. Yes, so B has E, which is unvisited. So push E onto the stack and copy E into the visited array. After this, as E is a leaf node, it is not having children. So pop E from the stack. And similarly, the next node on top of the stack is B, whose both children are visited already, that is D and E. So pop B also from the stack. Now A is there in the stack. So check whether A has any unvisited children. So out of B and C, B is visited and C is unvisited. So push C, visit C and copy C into visited array. So this is how we pushed C into stack and copied to visited array. So you can see in the visited array after A, B, D, E and C is there as they are visited after B and D. So now C is there on top of the stack. So there are two children for C, F and G. So push any one on top of the stack. So pushed A and copied F into the visited array. So C has a child F, so it is pushed onto the stack as well as copied to visited array. Now F is a leaf node, it is not having children. So pop F from the stack. Now check whether C has any unvisited children. Yes, so that is G. So push G. Now G is there on top of the stack, but G is the leaf node. So pop G. Similarly, then C will be there on top. So C is having no unvisited children. F and G are already visited. So pop C. So after popping G and C, A is there on top of the stack. But now A also have zero unvisited children because B and C are already visited. So pop A also from the stack. So this is how our stack is empty. And now we can check the sequence of nodes visited into the visited array. So it is A, B, D, E, C, F and G. So this was our tree, binary tree, and this is its DFS traversal. So we have started from A, then we go into the depth, A to B, B to D, then from D we backtrack to B, then from B we visited E, then we backtrack from E to B, B to A, then again we visited A to C, C to F, and then from F we backtrack to C, and then from C we visited G, and then from G again we backtracked from G to C and C to A. So A, B, D, E, C, F, G is our DFS traversal. So I hope you have understood this DFS traversal. Happy learning.